Hey guys, how's it going? You know what I did? I doubled the performance of OpenJDK. Yeah, I really did it. I know that it's a real bold title to say I doubled the performance, but actually, well, it is what I did in one single case. Certainly there are a lot of other cases where performance is not doubled. So let's begin at the start. What did I actually do? I noticed that there is several software out there which is using a loop to copy bytes or byte arrays from one input stream to one output stream, and that loops are using buffers, and that buffers sometimes are sized very large, and I wondered why they are using such large buffers while OpenJDK itself is using a very small buffer. So I thought maybe it is because of the performance, and I set up a test, and the test I measured simply was that loop with different sizes of the buffer, and the result was interesting, as you can see here. So this is always a loop, an array taken from an input stream written to an output stream with different sizes, starting with 8K, 16K, 32K, 65K, and 131K. So this is always doubled. The stream size was always the same, which was several megabytes. So what we expect is that the larger the buffer is, the faster the loop will run. And this is not true. Well, it is in part, but let's look at the exact numbers. With 8K, which was the original size from the buffer of OpenJDK internally when doing transfer to, we have a number of 1349 operations per second. And when we use a 16K buffer, so the double, we have 2632 operations per second. So we doubled the buffer and we doubled the performance. Actually, we did it. But if we double the buffer again, the performance only rises from 2600 to 2700. And if we double it again, it rises from 2700 to 2800 and so forth. So actually, yes, larger buffers always make it faster, but only slightly. The gain is lower and lower and lower. You need much more buffers to keep the gain of the performance rise. So to sum up, if we're going from 8K to 16K, apparently we have the biggest rise, and we have a really huge rise independent of the actual operating system, independent of the hardware you have used, independent whether it is an SSD or an HDD. So we did lots of tests with this JMH test on different hardware operating systems and so on. For example, there are numbers from another OpenJDK contributor, and where it is, he changed the test a bit. He actually introduced that the buffers are cleared. So he really wanted to know what is the difference between reading and writing into buffers, which was what I did. So caches, sorry. To writing directly into the hardware and reading directly from the hardware. So certainly using caches, which my test is doing, is much faster than his test, which does some tricks actually. We can see it here. For example, he's doing Linux tricks here to drop the caches, and he also introduces a call to the sync command on Linux to actually push the information from the operating system's file buffer into the actual hardware, which I did not. So his result was actually that he also has a huge benefit going from 8K buffers to 16K buffers, but it starts at 10% and it ends roughly at 20%. So what I wanted to tell you is the actual result depends heavily on your hardware architecture, on your operating system, and a lot of other factors. But always, the truth is that 16K is much faster than 8K, and increasing it lots more does not bring lots more performance. So what did we do in the end? The actual contribution I did is the smallest that you ever have seen. I just changed a single number in the source code of OpenJDK. I changed the default buffer size of input stream from 8K to 16K. You can find this contribution in OpenJDK 21, which is not out yet, but soon. And in OpenJDK 21, this will double your performance when you go from the input streams buffer to the output streams buffer, and not the input and output stream, but the operating system's buffer behind it and the hardware buffers behind it. So if you go from buffer to buffer, if you go from hardware to hardware, then it will only be 10%. To be fair, that's the truth. Anyways, to sum up, with OpenJDK 21, I just want to say 16, which is totally wrong. With OpenJDK 21, your performance will be better definitively, and it might be the double performance when you call the transfer to method, input stream transfer to. It might only be 10%, but 10% is better than nothing, isn't it? So that's my latest contribution. I hope you liked this contribution and the video. If you liked the contribution, actually, I hope that you not only will give a thumbs up, subscribe to our channel, and come back. I would be really happy if you would become my sponsor. If you want to do that, go on my GitHub profile, press the sponsor button. You will see a summary what I'm working on. It's open source, you really know and use, and would be glad if I would improve the performance of that. So please, a single $1 a month would be really enough to show you appreciation of my work, to appreciate what I have done to OpenJDK, for example, that I have doubled the performance in JDK 21, and a frequent donation is really, really appreciated. Thank you. So for today, I hope you like this video, give it a thumbs up, you subscribe to my channel, come back, write into the video comments whatever you think you need to tell me, what you'd like to see in future videos, or whatever I could improve in OpenJDK. So what else to say? Yeah, stay safe, and as always, party on!